Okay, number 7. Key to this is getting a good clear diagram, making sure all your forces and distances are clearly seen, okay, before you start doing anything else. So we've got a uniform plank AB of length 4.5 and mass M is resting on two supports X and Y such that AX and B equals BY 1.2. So the diagram is uniform, so the weight is in the middle. The mass is M, so the weight is mg. Two supports, there's A, there's B. AX is 1.2, well this is 2.4 to the middle, so the first support is there, that's at X. And the second support is BY, that's in the middle as well. So if I got a support there's a contact, and because the contact is a reaction, Rx, Ry. All these distances are 1.2 meters. Okay, part A. A person of mass 84 stands on the plank at a point which is 0.8 from B. So we've got this person here, mass 84, so that's 84g is the weight. That's 0.8. So that there must be 0.4. So the one. Okay, so there's all the forces. It says the reaction of the support at X is of magnitude 156.8. So they give me the value of Rx. I want to find M and Ry. Okay, easy equation first of all. If it's in equilibrium, forces up equals forces down. So going up then I got 156.8, add Ry is equal to mg plus 84g. That's the easy equation. Now I need to take moments. Now then, because Rx is known, if I didn't know Rx I probably would have gone about X. Because Rx is now a known value, I'm either, the best place to take moments now is either about the centre or about Y, because I'd be taking out an unknown value. Okay, so I'm going to take moments about Y, and that way Ry won't be in my equation. So taking moments there, remember I want the sum of the clockwise moments equals the sum of the anti-clockwise moments. So I'm turning about Y. So the 84g is turning it clockwise. The 84g force is 0.4 away from Y. So that moment is 0.4 times 84g. That's clockwise. Moving to the mg. The mg will turn it anti-clockwise. That mg is 1.2 meters away from Y. So it's an anti-clockwise moment, so it's on the other side. So that's 1.2 times mg. The Rx, the 156.8, about Y will turn it in a clockwise direction, and that force is 2.4 meters away from Y. So it's a clockwise, so that needs to be added to the clockwise moment, and that's 2.4 times 156.8. Now if you look at that equation there, the only unknown I've got is M, so I'm now able to calculate M from what I've done there. So 0.4 times 84 times 9.8. So that is 329.28. Add 2.4 times 156.8. 376.32, and that equals, right, mg there, 9.8, so it's 1.2 times 9.8. That's 11.76 m. So add these two up on the left hand side. That's 705.6 divided by 11.76. That equals m. And that equals 60 kilograms. Okay, and that's part one. And part two wants the magnitude, so part two wants the value of y. So going up to the first equation then, one, so one is giving me 156.8 plus ry, which is what I want, equals mg, so that's 60 times 9.8, add 84 times 9.8. So ry, we're calculating those out, 60 times 9.8, add 84 times 9.8, take away 156.8 equals 1254.4 newtons. Okay, so first part of the question, pretty standard really. Alright, there's two unknowns within the question, and basically you set up two equations to be able to calculate those two unknowns. Alright, when you take moments, make sure you take moments about a point which is taking out one of the variables. Okay, then the algebra will be much easier for you. And then the second part, it now says the person of mass 84 walks along the plank towards A. At the instant that the plank starts to tilt about x, find the magnitude of the reaction of the support at x and the distance of the person from x. So I'm just going to change my diagram. A, B, these supports obviously are still at the same distance. The weight is still uniform, so there's a force of 60g acting down. The reactions I found in the first part are now not the same because I've actually changed the position of this 84 mass. We've got it to walk towards A, right? I don't know how far. When it does, the consequence of walking along there is this plank is going to tilt about x. Yeah? So, if the condition for the plank to tilt about x, if it tilts about x, okay, then the reaction at y isn't going to become 0, because if it's tilting about x, it's going to start doing that, and the contact at y is broken. So if it tilts about x, the reaction at y is going to equal 0. Okay, so we get this. We move the mass of 84 along, 84g, and I want the distance of the person from x. So this person is the distance of x from x. Okay, so it's tilting about x, the reaction at y is 0, so there is a reaction here at x. Okay, nothing's happening here, that reaction is gone. Okay, that's 1.2 meters, that's 1.2 meters there. The middle. Okay, now then again, two equations. Forces, let's take that out of the way, stop confusion. Forces up equals forces down. So I got Rx is going up, 60G plus 84G down. So I got that reaction straight away from that equation. And then to find X, I need to take moments. I suppose the obvious place to take moments, I hope, you agree with me, is X. Okay, so I'm going to take moments about X. Then I'll have 1.2 times 60G, that's clockwise. Also, X times 84G is also clockwise. And that's going to equal 0. Now then, that implies now I'm going to get a negative distance of X, which isn't surprising really, because I suppose this person has obviously walked past X and gone closer towards A. And I'm going to end up with a negative value for my X to indicate that. Okay, but it doesn't matter where I put it, the maths will take care of it. So let's calculate our X first of all. Let's get the easy marks. So 60 times 9.8 plus 84 times 9.8. So that's 1411.2 newtons. That's answer to part 1. And then working this out, 1.2 times 60 times 9.8. So 705.6 plus 84 times 9.8. That's 823.2x equals 0. 823.2x is minus 705.6. X is minus 705.6 over 823.2. That's giving me minus 6/7. Okay, I can't leave it like that obviously, so obviously it's to the left of X, right? So the distance is 6/7 of a meter left of the point X. Okay, because I didn't set up in the right position in relation to X, I need to explain why I've got a minus.